This video will show you how to create a custom map. A custom map is a map that you convert from a shapefile. The shapefile contains the boundaries of the regions that define the map. Before we look at how you can create such a custom map, let's first take a quick look at the built-in mapping feature. We'll create a new dashboard based on a sample data set stored in a worksheet called census data. We'll use the built-in map feature to plot a measure on a map of the United States. To do this, we add a chart component, open the chart editor, find the geographic field that we want to use, in this case the state field, and designate the field as a geographic field. To do this, right-click the field and select Set Geographic. This opens the Edit Geographic dialog box where we can select the type of map that we want, the layer represented by the field that we selected. In this case, the defaults are correct. We want a US map, and the field that we selected here does in fact contain states. Therefore, it should be mapped to the state layer. Press OK. Then switch the chart to a map type chart. Place the geographic field in the G region in the chart editor, and then display the desired measure by using one of the visual properties, typically color or shape. Press Finish Editing to complete the map. To display values on the geographical regions, you can either right-click, select Plot Properties, and choose the Show Values option, or in the chart editor, you can bind a field to the text region. For example, here we might choose to bind a measure such as federal spending. This is the built-in mapping feature. As you saw, when you use the built-in mapping feature, you can choose from one of several different built-in maps. These include US, Asia, Canada, Europe, Mexico, and World. However, in many cases, you may want to create your own map. For example, you might need a map of just one of the states, such as California, perhaps with a representation on the map of the different zip codes in that state, or the different voting districts. In other cases, you might need a map of a country or a continent that is not provided in the built-in list. In still other cases, you might need a map that is not a geographic map at all, but rather is a map of a warehouse, or a housing development, or something of that nature. All of these different kinds of maps can be created with the approach that we'll show you now. This approach relies on something called a shapefile, which is a definition of the geometry of a map. You can create shapefiles yourself, or you can download them from a wide variety of sources. For example, the United States Census website contains shapefiles that can be downloaded. There are many other government and industry websites that provide shapefiles. Once you have created or downloaded the shapefile that contains the definition of the map geometry that you're interested in, you will need to use a program called OpenJump. This is a free third-party program that can take a shapefile and convert it into a map that can be used together with the iNetSoft application. You can download OpenJump from the project website shown here and install it as you would any other application. After you've installed OpenJump, you will also need to install an iNetSoft plugin that will provide the features that will allow you to easily convert a shapefile into an iNetSoft map. The iNetSoft documentation explains how to obtain the plugin and how to install the plugin into the OpenJump installation. Once you've installed the plugin, you are ready to convert a shapefile into an iNetSoft map. In the following steps, we'll create a new map of the United States from a downloaded shapefile. We've already installed the iNetSoft plugin into our installation of OpenJump, following the instructions described here, so we can now run OpenJump and begin processing the shapefile. This is the free OpenJump application. Note that among the menus in the menu bar is an iNetSoft menu. This will provide a set of steps that we can follow to convert a shapefile into an iNetSoft map. To begin, we'll open the shapefile that we want to work on. For this example, the shapefile is called states.shp. This is the shapefile that contains the outlines of the United States. To prepare the shapefile to be used as an iNetSoft map, we'll proceed through the steps in the iNetSoft menu. The first step is Consolidate Features. This will logically group together states that might have discontiguous regions. Select Consolidate Features and choose the layer and ID attribute that you want to consolidate. The default settings here are correct. Press OK to perform the consolidation. Note that this creates a new layer in the map. We now have the original states layer and a new states consolidated layer. This will happen every time we perform an operation, so we could potentially end up with many different layers of the map. In this case, we don't need to keep those precursor layers, so we can delete the original states layer. This leaves us with just the consolidated layer. To move Alaska and Hawaii into the familiar positions that you're used to seeing them on a map, return to the iNetSoft menu and select Create US Inset. Select the layer that you want to operate on, States Consolidated, and press OK. Again, this creates a new layer, but we can remove the original layer. This keeps our work in progress as simple as possible. We'll recenter the map by going to the View menu and selecting Zoom to Full Extent. The next step in preparing the map is to remove unnecessary polygons. To do this, go to the iNetSoft menu and select Area Histogram. This performs an analysis of the map, and you can view the report of this analysis by pressing the Output window button in the toolbar. This provides a set of thresholds that you can use to remove a certain percentage of the polygons in the map. For example, if you select the threshold of 21.98, this would remove approximately 90% of the polygons in the map. This, of course, would be a very substantial simplification of the map and would save a lot of memory, but it might also produce a coarser representation of the geographical space. You may need to try multiple thresholds to obtain a version of the map that is as simple as possible, but not simpler. For this example, it turns out that a value of about 0.02, which removes about 40% of the polygons, seems to work nicely. Once you've decided on your threshold, close the window, and then proceed again to the iNetSoft menu and select Remove Small Polygons. Enter the threshold that you've decided on. In our case again, we've decided on 0.02, and press OK. This creates a new layer with small polygons removed as per the threshold that we just entered. We'll remove the previous layer. The next step is to reduce the precision. Return to the iNetSoft menu and select the Fine Precision option. Select the layer, press OK, and then again press the Output Window button to view the current precision of the map. Here you can see the number of decimal places is 14. To change the number of decimal places, close this window, return to the iNetSoft menu, and select Node Lines and Polygons. Enter the desired precision. 6 will work well in this case, and press OK. Again, this results in a new layer, and we can remove the precursor layer. Finally, we'd like to reduce the number of points that define the lines in the map. Again, to save space and to simplify the representation of the map, return to the iNetSoft menu and select Point Threshold Histogram. To view the result, press the Output Window button, and this again displays the percent of points that can be removed by entering a particular threshold. In this case, a threshold of about 0.01 can remove between 80% and 90% of the points. Close the window, return to the iNetSoft menu, and select Simplify Lines and Polygons. We'll enter a threshold of 0.01. That will cause the removal of most of the points defining the boundaries between the states. Remove the precursor layer, and now we have a map that is suitable to be exported for use with the iNetSoft application. Select the final layer, return to the iNetSoft menu, and select Export Layer. Press the Browse button and navigate to the SREE Home directory of the iNetSoft application. On a Windows machine, the SREE Home directory is in the following location. The server-config directory within the iNetSoft Technology folder in the Windows Program Data folder. The name of the map that you export must be mapdata.xml. If the name of the exported map is not mapdata.xml, then the iNetSoft application will not be able to find the map that you created. When you save mapdata.xml, this also saves a couple of CSV files into the same location. Set the map type. This is the name of the map that will appear in the iNetSoft application. For our example, we'll call this USA Custom. The layer name we'll call State Custom. Note that when you create a custom map, the map type should not be the same name as any of the built-in map types. In most cases, the layer name should also be different than the layer names of the built-in map types. For the feature ID, select the same field that you originally consolidated the map on in the first step. That was the state_name field. You can also select an alternate name that you might want to use to help match up the geographical regions in the map with the values in data fields that you'll be plotting on the map. For information about the coordinate settings at the bottom, please see the documentation. Once you've configured all these export settings, press OK to write the mapdata.xml file and the associated CSV files. We now have a custom map that we can use in the iNetSoft application. At this point, you should restart the iNetSoft server to make sure that the server picks up the new custom map. Let's do that and then return to the user portal to create a new dashboard. We've now restarted the server and returned to the user portal. Let's create a new dashboard. Again, based on the sample census data worksheet. And this time we'll create a map based on the custom map that we just exported. Here again is our state field in our data source. We'll right-click and select Set Geographic. And this time we'll select our USA custom map. This, of course, is the map that we exported from OpenJump. The layer will be state_custom. The check mark next to the mapping field indicates that all of the values in the state field of the data source have been correctly mapped to state values in the map. Press OK and then proceed to set up the map. Switch the chart to a map type chart. Add the state field as the geographical region, and then add the desired measure that you want to plot on the states. We have now created a custom map using the US shapefile that we downloaded and converted in OpenJump. What we'd now like to do is add an additional layer to this map. We'd like to have a layer that shows the different census regions. These include West, Midwest, Northeast, and South. The built-in US map does not have these census regions defined, so we'll have to do this using a custom map. To do this, we'll return to the OpenJump application and add a new layer. Let's stop the iNetSoft server and then return to the OpenJump application. To add a new layer with the census regions, first click the View/Edit Attributes button in the toolbar of the OpenJump application. This opens the Attributes window. Right-click on the table and select Editable. You can now select different states on the map or groups of states and combine them together. Let's first select all of the western states. You can do this simply by dragging across the states that you want to select. These are the states in the West region for the US Census data. Right-click on the states that you've selected and choose Combine Selected Features. This merges the selected states into a single entity. Let's repeat this process to define regions for Midwest, Northeast, and South. These are the Midwest states. After you've selected them, right-click again and choose Combine Selected Features. These are the Northeast states. Again, select them, right-click, and Combine Selected Features. Finally, the remaining states are the South states. We can select these by selecting all of the states, and then deselecting the regions that we already defined. Shift-click to deselect West, Shift-click to deselect Midwest, and Shift-click to deselect Northeast. This leaves the states of the South region. Right-click, and then combine these features. Again, press the View/Edit Attributes button in the toolbar. Then right-click the table and select View/Edit Schema. This opens the Edit Schema dialog box. In an empty row beneath the other rows, double-click to create a new attribute. We'll call this attribute Region, and it will have type String. In the Attributes dialog box, we can now enter values for the different regions. Note that in the Attributes dialog box now, each of the regions is represented by a single state in the region. So we can enter the values for our regions. As you click on each region, this highlights the region on the map. There is one further thing that we need to do, and that is to make sure that all of the regions are represented as multi-polygons. If we don't do this, when we try to use the map in the iNetSoft application, we'll receive an error to the effect that not all of the regions are represented as multi-polygons. To address this, select the whole map, go to Tools, Edit Geometry, Convert selected geometries/layers to, and then select multi-polygon. We can now export this as a new layer into the same mapdata.xml file that we created previously. Return to the iNetSoft menu. You do not need to repeat any of the steps that we did previously, so just select Export Layer. The map file again is the same mapdata.xml file that we saved before. The map type will be the same map that we specified earlier, but the layer name will be different. In this case, we'll call it Region Custom. The feature ID in this case should be Region. And in this case, we do not have an alternate name. Press OK, and then restart the iNetSoft server and return to the user portal. We've restarted the iNetSoft server, and now we'll create a new dashboard using the region layer that we added to our custom map. This time, since we want to plot a measure region by region, we'll use the region field in our census data worksheet as the geographical field. Right-click the region field and select Set Geographic. Choose USA Custom as the map. This again is the custom map that we created. And this time select Region Custom as the layer. Note that this map now has two available layers that you can use to plot a measure. To plot a measure region by region, we select the Region Custom layer. Again, the check mark at the bottom right indicates that all of the values in the region field of the data source are correctly matching up with regions defined in the map. To verify this, you can press the geo icon here and observe that the values in the dataset do indeed match the values available in the map. Once the region field has been designated as a geographical field, you can set the chart type to a map, and then add the region field to the geographical binding. To display a measure region by region, simply drag the desired measure to one of the visual bindings. Here we're displaying the summed federal spending region by region. You've now seen an example of creating a custom map with multiple layers. This allows you to plot data at multiple levels of granularity on a map type chart. Let's look at one more feature of OpenJump, which is the ability to import multiple shapefiles and create a single map out of multiple shapefiles. Let's return to OpenJump and let's create a new project. First, let's open the US map, as we did earlier. And now let's also open a shapefile that defines a Canada map. This downloaded map has multiple shapefiles that define different levels of resolution of the map. For this example, we'll use the shapefile called can_adm1.shp. It may take a moment or two to load. You can see that we now have two maps, a map of the US and a map of Canada, and we'll repeat this to include a map of Mexico as well. Here again, we'll choose the adm1.shp file. If we want to use these three shapefiles as a single map, what we'll need to do is to combine them. Select the three layers, right-click, and select Combine Selected Layers. This creates a single map containing the three layers. There's one further step that you should do in this case, and that is to create a new column in the schema that provides names to the different regions on this new map. You would do this the same way that we did it before, which is to press the View/Edit Attributes button, right-click and select View Edit Schema, add a new column, and then provide a name for each region on this new map. That would include the states of the US, the provinces of Canada, and so on. You could then proceed to use the other operations available in the iNetSoft menu, and then finally export the completed map. There are many other features provided by OpenJump. As you can see from the many toolbar buttons and menus available, please consult the OpenJump documentation for full information about all the features in OpenJump.